Before we wrap this class up, let's do a review with some questions. How do you multiply proper and improper fractions?
To multiply fractions, whether proper or improper, multiply the numerator of one fraction by the numerator of the other fraction. Do the same for the denominators, but independent of the numerator.
What does the process of cancellation while multiplying fractions mean?
It means reducing the fractions to their lowest terms before multiplying the fractions. This is easier than after the fractions have been multiplied.
How would you solve a fractional multiplication involving mixed fractions?
First, express the mixed fraction as improper fraction before multiplying the fractions.
If a fraction is multiplied by a whole number, how will that be solved and why?
That's simple. Just place the whole number over 1, then multiply. This is because a whole number is a complete number. It is not broken into parts.
Now let's solve the following problems. A. 7 over 9 times 27 over 35. To multiply this set of proper fractions, we'll first reduce the numerators and the denominators to their lowest terms before proceeding. Hence, first look at the numbers and check which ones can both be divided together without a remainder. You will notice that 35 can be divided by 7 in 5 places. From your multiplication table, 7 times 5 equals 35. Hence, 7 in 7 is 1, while 7 in 35 is 5. Look again. Which ones can be further reduced? Can 5 divide 27? Of course not. But how about 9? Again, the multiplication table makes this easier, and the answer is yes. So, 9 into 9 will give 1, while 9 into 27 is 3. Now that's good. Therefore, the resultant fraction now is 1 over 1 times 3 over 5. Since 1 over 1 is 1, and 1 times any number is that number, your guess is as good as mine. Did I hear you say the answer is 3 over 5? Brilliant student.
There's a key lesson here for us. Did you notice that we only reduced the fractions to arrive at the number? We did not even do a single multiplication. Okay, let's look at another problem. B. 20 whole number 5 over 8 times 3/4. This may seem complex, but trust me, it's not difficult to solve. Recall that in the class on forms of fractions, we said that fractions can be expressed using a slanting line or solidus. So, 3/4 is the same as 3 over 4. Also, first express the mixed fraction as improper fraction before proceeding. From here, you wouldn't find it difficult to solve. If you are stuck, just do a quick review of the class on forms of fractions. Or would you prefer a quick fix? Just say 8 times 20 plus 5. Then place the result of the operation over the denominator 8. So let's start. 8 times 0 is 0. Write it down. 8 times 2 is 16. Write it before the 0. Then add 5 to the 160 you've got. You will have 165. Now, your fraction is 165 over 8 times 3 over 4. If you look well at these fractions, you will notice they cannot be reduced any further than they are. 3 cannot divide 8 without a remainder, and neither can 4 divide 165 without a remainder. So we multiply directly. 165 times 3 is equal to 3 times 5, which is 15. Write 5, keep 1 aside. 3 times 6 is 18, plus the 1 we kept aside is 19. Write 9 before the 5. Keep the 1 aside. Finally, 3 times 1 is 3, plus that 1 we kept aside, equal to 4. Therefore, the new numerator is 495. To find the new denominator, we will say 8 times 4 equal to 32. If we like, we could have the answer as it is, but to express it as a mixed fraction, we will divide 495 by 32 to have 15 whole numbers, 15 over 32.
Wow, that's impressive.